Hi, this is problem number 4 on coplanar non-concurrent system of forces. The question is to determine the position of the resultant of the force system if the external moment of M is equal to 3 Newton meter 3 Newton meter at the point P 20, 10 is acting as shown in figure. Okay, the coordinates of this point P are 20, 10. X ordinate is 20, y ordinate is 10. Okay, so if the coordinates are 20 and 10, see for the point B, x ordinate is 20, so total x distance is 20. Therefore uh, the distance or length of each grid will be how much? It will be 10. It will be 10. 10 and 10. So the dimension of the rectangle are not given here in this problem. What it is given is the coordinates of the point P. Okay, referring to the coordinates, we have to find the length of the rectangle, or the, I think it is square. Yes, it is square, the length of the square. So y ordinate is 10. Y ordinate is 10, which means that each grid is having 10 mm length. 10, 10 and 10. Okay, now what is the question? We have to find position of the resultant force. Okay, for the given system of forces, there are few forces acting on the plate. Okay, we have to find the position of the resultant force. Now initially we have to write the components for inclined forces. We have two inclined forces, 200 Newton and 400 Newton, and for them inclination is not given. We have to find it. We have to find the inclination, means angle theta 1 and theta 2 we have to find. Okay, so here, so this is not the theta 1, it is theta 2, because opposite angles are equal. So here the same thing, it is theta 1 here. Okay, now what I will do is I will name these points as point A, point B, and this point as point C. Okay, point C. Okay, now I will tag this as point D, this as point E, and point F. So for the calculation of the angles. Okay, now consider from, okay, from triangle ABC, from triangle ABC, if you measure theta 1, it will be tan inverse of opposite by adjacent. Opposite is 1 2 3 4, 4 grids means 40 mm, divided by adjacent side is 2 grids 20 mm, 40 by 20, 40 by 20. So by this you will get the angle theta 1 as 63.43 degrees, 63.43 degrees. Then you take the right angle triangle DEF. Now from right angle triangle DEF, theta 2 is equal to tan inverse of opposite is 3 grids 30 mm divided by adjacent is 10 mm, 30 by 20, 10, tan inverse of 30 by 10. Okay, the angle is 30 by 10. No, tan inverse of 30 by 10. Let me calculate it. shift annuals of 30 by 10. It is 71.56 degrees. 71.56 degrees. Okay. Now you got the angles. You can write the components now. For 400 Newton force, horizontal component is 400 cos theta 2 is 71.56. Vertical component is 400 sin 71.56. Okay. Then for 200 Newton force, theta 1 is 63.43. Therefore, horizontal component is arrow mark will be towards the plate here because the force 200 Newton is acting towards the plate, towards the corner. Horizontal component will be 200 cos theta 1 is 63.43. Then vertical component will be 200 sin 63.43. Okay. So to this we have written the components. Next step is to calculate the magnitude of the resultant force. For that we need sigma fx, sum of forces in x direction, plus 200 cos 63.43. Correct. It is acting in right direction, sin is plus. Then here we have 150 Newton force acting in right direction, sin is plus 150 Newton force. Then here we have two forces, 400 cos 71.56 and 100 Newton, plus which both are acting in right direction, plus 400 cos 71.56 plus 100 plus 100. Okay. So for this uh, answer is 200 cos 63.43 plus 150 plus 100 plus 400 cos 71.56, 465.98. Newton. Okay. Then sigma fi is equal to sum of forces in vertical direction. So 200 sin 63.43 acting in upward direction, sin is plus 200 sin 63.43. Then 250 Newton force acting in downward direction, sin is minus 250. Then we have 400 sin 71.56 acting in downward direction, sin is minus 400 sin 71.56. That's all the vertical forces we have covered. Therefore sigma fi is equal to 200 sin 63.43 minus 250 minus 400 sin 71.56. It is minus 450.58, minus 450. 460.58 Newton. Now resultant force R is equal to root of sigma Fx square plus sigma Fy square, which is equal to root of 465.98 square plus 450.58 square. So I'll not take the negative sign, because when you make it square it will be plus only, minus into minus plus. So root of 465.98 square plus 450.58 square is 48.19 Newton. The angle theta will be equal to, theta is equal to tan inverse of sigma Fy by sigma Fx. Theta is the inclination of the resultant force. Tan inverse of sigma Fy is minus 450.58 divided by 465.98. Therefore tan inverse of 450.58 divided by 465.98 minus 44.03 degrees. Okay, this is the theta. Then it is asked to find position of the resultant force. So you can find moment about O. Okay, so whatever the coordinates of the point P given, no, they are given with respect to the point O, no. So better to find moment about O, and with respect to the O we will get position of the resultant force. Therefore sigma MO is equal to see moment of this 200 Newton force. Okay, moment of 200 Newton force about point O becomes 0, because force is passing through the point O, or point O lies in the line of action of 200 Newton force. Directly you can write 200 into 0, 200 into 0. Then coming to the moment of 250 Newton force, no, if you draw the line of action, so this is the line of action of the 250 Newton force. So therefore point lies in the line of action of force. Okay, point O lies in the line of action of 250 Newton force. Therefore moment of 250 Newton will also become 0, plus 250 into 0. Then we will take moment of 150 Newton force. 150 into the perpendicular distance is, you just draw the line of action of the force. So this is the line of action of the force. This is the line of action of 150 Newton force. We have the point O here. Distance of point O from the line of action is how much? 1, 2, 3, 4, 40 mm into 40 mm, 40, and about point O, if you apply a 150 Newton force at this corner, the plate will rotate in clockwise direction. Sign is plus. Then moment of this 100 Newton, okay, moment of 100 Newton and moment of this 400 cos 71.56 force about point O becomes 0, because if you draw the line of action for both the forces, this is what the line of action of the forces, right? Therefore point O lies in the line of action of force. There is no distance of point O from the line of action. So moment of both the forces become 0. Let me write the same thing here. 400 cos 71.56 into 0. 400 cos 71.56 into 0 plus 100 into 0. So plus or minus it will be 0 only. Even if you do not write this calculation, no problem, because its value is 0 now. Now you take vertical component of 400 Newton, that is 400 sine 71.56, 400 sine 71.56 for 400 sine 71.56. So this is the line of action. This is the line of action. The force is vertical, distance should be horizontal. Correct? This is the line of action. Here we have the point O. Distance of point O from the line of action is how much? 40 mm. And if you draw vertical force, if you apply vertical force at this corner, about point O, the plate will rotate in clockwise direction, sign is plus. Therefore, 471.56 into 4, sign is plus. Then, so I think we have covered all the forces, calculation of moment of all the forces, and at point P, there is a clockwise moment of magnitude 3 Newton meter. Okay, 3 Newton meter, 3 Newton meter. So it is a clockwise moment, right? Clockwise moment means for clockwise moment sign is plus, plus, plus. What is the magnitude of the moment given? 3, plus 3. That's it. Okay. Don't multiply the distance. It is already the moment. It is already the moment. Don't multiply the distance. Okay. 3 Newton meter. If it is clockwise moment, you need to take the plus sign. If the moment given is in anti-clockwise direction, then you need to take the negative. Whatever the value given, just directly you take that value. Okay, it is a clockwise moment of 3 Newton meter, so plus 3, that's it. Okay, so while doing the sigma m naught only, this value will be taken. Okay, and while finding sigma fx and sigma fi, this moment will not come into picture, only the forces will come into picture. Now we will calculate sigma m naught. Sigma m naught is equal to, so 200 into 0, so this value becomes, let me, so this is 0, this value is 0, this value is 0, this value is 0, this value is 0. Therefore the 150 into 40, then 400 plus, plus or minus is plus 400 sine 71.56 into 4 into 4 and plus 3. It is 7520. 7520. 7520 Newton millimeter is the answer. Force is given in terms of Newton and distance is given in terms of millimeter, so the unit will be Newton millimeter. Now you can find x-intercept. X-intercept is equal to sigma m naught divided by sigma fi, sigma mo, sorry, mo 7520 divided by sigma fi is 450.58. 7520 divided by 450.28, sorry, 458, no, 7520 divided by 450.58, 16.7 or 16.68, 16.68 millimeter. Put the answer with a positive sign only because mod is there. Y-intercept is equal to, Y-intercept is equal to sigma m naught divided by sigma fx, 7520 sigma fx is how much it is? 465.98. 465.98. We'll calculate the answer. 7520 divided by 465.98. 16.13 mm. 13 mm. Then the D is equal to sigma m naught divided by R 7520 divided by, what is the magnitude of the resultant force we got? 648.19. 7520 divided by 648.19. 11.60 millimeter. 11.60 millimeters. To this, we have determined position of the resultant force. Okay. So to this, solution of this particular problem is over. Thank you.